Hello and welcome to the Roundtable High Efficient Axial Fans here at the Chillventa eSpecial. My name is Uwe Martin. I'm the head of product management Axial Fans and I'm working since almost 10 years for ZIEHL-ABEGG. Today I will lead this round. Efficiency and energy saving has dominated the refrigeration market within the last decade. Also, the European government has this topic on the focus. Since the Eco Design Directive 2009, there's a framework how we can reduce the power consumption and the CO2 emission. Within a refrigeration unit, a fan is a very important component, sometimes with high power consumption. Today, we will discuss about opportunities, how we can increase the efficiency and how we can reduce the CO2 emission. Before I introduce my colleagues, let me say a few words to the process. Within the last couple of weeks, we received a lot of questions from our customers, and based on these questions, we set up this roundtable. If you have further questions, you can use the chat function and enter your comments. Our administration team will receive them and try to involve them to the discussion. Otherwise, you can get in contact after the roundtable with each of the colleagues. So, let me introduce my colleagues. To my left side, we have Michael Kraus. He's a product manager for Axial Fans for almost 3.5 years. Additionally, he's an expert in the field for heat pumps. Michael, welcome and thank you very much because you jumped in this morning as a replacement.
Thank you very much. It's a pleasure to contribute to the discussions.
To my right-hand side, we have two colleagues from the sales. Marco Rüttgers, he's a project engineer since almost 12 years in the export department. Additionally, he's a key account manager for a global customer. Today, Marco is our international expert. Welcome, Marco.
Thank you, Uwe.
And we have Torsten Friedrich, also a project engineer since almost 5 years. He supports our German customers by the right fan selection, and today he is our German expert. Torsten, welcome.
Thank you, Uwe.
All right. The next 30-35 minutes, we will discuss about options, how we can increase the efficiency, especially for AC fans. Before we start this discussion, I want to take a look back in the time. 2013 and 2 years later, 2015, the ERP requirement sets a minimum efficiency value for fans. So my first question is, maybe more to our sales colleagues, how did the conversion work at that time and what is your experience?
Yes, so back in 2015, of course, the ERP affected us as well. We had to scan through our portfolio and through the portfolio of the customers in order to find which fans need to be replaced or need alternatives. So we got in contact with these customers and looked for alternatives together in order to have ERP compliant solutions. I think it was not that hard at the time because ZIEHL-ABEGG already had a portfolio with a lot of fans that were above the minimum efficiency level. So it was not that hard to find alternatives for the customer. But that's only speaking for the European market. I don't know, Marco, do you have the same experience?
Yeah, personally, for me, it was not the main focus at that time because I was responsible for North and South America. And in these countries, this regulation by law was just not in place. But nevertheless, these countries very often follow what's going on in Europe. And also they want to sell their products to the European market. So they also step by step got involved into the ERP regulations. So at that time in 2013 and 15, it was quite easy to have replacements which didn't hit the target of the tiers at that time. It were mainly single phase AC fans, so we had good replacements for similar AC fans, or they did the change to EC fans. But all in all, it was not a big challenge. I think the new regulation tier, which might come in next year, so we don't know the date yet. But this will be a bigger challenge also for the customers in the internationals.
Okay, thank you, colleagues, for sharing your experience. Now we have 2020, and the market is waiting for the next ERP requirement. We heard in the last 2 days that it looks like that the new tier will come into force in 2-3 years. So let me say 2023. So do the customers already have that topic in mind, that a new ERP tier is coming?
I would say the main focus of the customers the last years was more on their use of refrigerants. So they had to check with which refrigerants to use. They had to look at the F-gas certification and look if their unit needs ATEX components now. So that was the main focus of the customers until now. Now it's shifting back to the ERP topic again. And I bet I'm not the only one looking through the customer portfolios again. Right, Marco?
That's completely right. For me, it's a very, very hot topic right now, especially with my key customer who has a big, big business in the European market. So I'm in this discussion with them already since weeks about the targets, what they need to fulfill, about which products they can still use, which they already use in their products, and for which of the products they get from us, we might need to do some changes. But here, the important thing is that we are in detailed discussions with them. Everybody wants to be prepared if the tier really comes in place, because if it comes in place, it's too late to start. So we really need to start now discussing about it, and we are doing that, and I'm very optimistic that we find solutions together, because the new developments of our also Axial products are of a big help here to really get a solution for our customer.
Okay, let us talk about the new requirements. I think the draft shows a little bit higher values, and for this case, we prepared a diagram which we can share now with our listeners. And here you can see 3 different curves. The blue line shows the requirement for 2013. As you explained from your experience, the difference between the requirement from 2013 and 2015 was not that difficult. The jump was not so huge. But if we look at the green line, the minimum efficiency values from the current draft, it's a bigger increase. For our participants, if you see the rise of the curve, it's a different calculation formula behind that. Nevertheless, it looks like that it's a more tough challenge. So maybe a question more to Michael, our product expert. What can the customer expect with the new ERP tier?
Well, this is not an easy question to answer. This might be different from customer to customer, of course. Those customers who already use efficient products, for example, our ZA Plus with an EC or ZA Plus with an AC, they won't have big issues there. This will be possible relatively easy. Those who are not compliant, who use products which are not compliant yet, they will have to think about replacing the products. This will be a little bit of an effort. This needs a lot of conversation and discussions between the OEMs and us as a manufacturer. But there is for sure more than one solution possible here. And possibly it comes with some mechanical issues or with an issue of a recertification. But this isn't a big deal after all. And for sure, this ERP directive offers a chance for more success and more efficient products as well, in my opinion.
Okay, and what do you expect for the market? I think there will be different scenarios also for customers as well as for ZIEHL-ABEGG. So the concrete question is, what do you expect? Which scenarios we should prepare for?
Yeah, as you just mentioned, there's different scenarios. For the European Union, of course, the ERP directive is mandatory to achieve. Yeah, but there might be markets which are not in the European Union where ERP isn't mandatory to achieve. And regarding the European Union market, the customers, or most of them, are already ready or have already started discussions to achieve the ERP directive. Others might have to change, possibly. And then is a question for their individual perception of the situation. Possibly there are some who go for 100% ERP compliant products. Others might go for an AC and an EC solution, or a solution ERP compliant or not ERP compliant at the same time. So both strategies, in my opinion, might show some benefits, sometimes reducing article numbers or having a specific product for a specific market with a specific fan then. So in my opinion, there isn't just a black and a white. There is a lot of beautiful colors in between, solutions we can offer here. So I think we are prepared very, very good with ACs and ECs as well.
Okay, so how about the older fan ranges? I know ZIEHL-ABEGG have a wide range of different Axial products. Are they able to fulfill the next ERP tier?
Yeah, Uwe, let me answer this question. For sure, we still have a lot of products in place in the market from our older range because customers are using that for years. It's a running system, and everybody knows the saying, never change a running system. So for them, there's no direct need to change these older ranges. But like mentioned, these older ranges probably will not always hit the target. So we need to look for alternatives, and we need to look for fan solutions which hit the ERP targets to be able to still supply them to the market. So ZIEHL-ABEGG supports the customer in this change, and we are there as the partner to tell them, okay, this product is still available, or we need to change to a newer, more efficient product in AC or in EC, whatever is needed and the best fit for the customer.
Yeah. So let me add some point here at this point. Yeah. So if we are not ERP compliant with the fan, actually, for sure we have to look for solutions, and we think we have a lot in the portfolio, like our ZA Plus, providing a lot of efficiency surplus here. So there is possibly the need to replace for more efficient fans here, for sure.
Exactly, I fully agree.
Okay, thank you. I know ZIEHL-ABEGG develops always new products, new motors. So one question we received in front of the Chillventa eSpecial from customers was, does ZIEHL-ABEGG focus only on one motor technology?
Possibly that's a question for me, Uwe. No, definitely not. We do not only focus on the motor here. For sure, the motor is the heart of a fan. Yeah? It's the driver of the whole system. But as I just said, we are a system provider. We do not provide only motorized fans. So there's a lot more components involved here, like a nozzle, like the impeller. So it's not sufficient to concentrate only on the motor efficiency. And we have always analyzed on the whole fan, not on the impeller itself. So there's a lot of different aspects and properties we have to think about.
Okay, so let me summarize your statement. It means ZIEHL-ABEGG is developing high-efficient Axial fans with different motor technologies.
Yes, definitely we do. For sure, the trend is easy. That's very clear. A lot of devices require controllable speed, but still AC is needed. If you have an operation 24/7 full load, there is possibly not really a need for an EC. You can go for an AC easily. So there might be further on some special requirements like low temperatures up down to -60 degrees C. So, and this can only be achieved by an AC easily. And therefore, we decided to provide EC and AC fans in the future, ERP compliant, over the full range.
Okay. And the question maybe to our sales colleague, is the market requirement AC fans, AC motors?
Yes, I think Michael just mentioned, made a really important point. I think there's a lot of applications that don't call for an EC, that don't need a difficult control mode or a seamless speed control, that just need to run at their full speed. And yeah, as mentioned, the EC has limits as well, and there are applications that don't need an EC, or the AC is even the only choice for this special application.
Exactly.
Okay. So then I would suggest let us take a closer look. Yeah? Torsten, you mentioned the market still need AC fans. So the question, the topic of today is how we can increase an AC fan to fulfill the next ERP tier. So which options do we have to make a fan more efficient?
I'll take that one. Yeah, in general, it's not that easy to achieve higher efficiencies with a fan because we're already on a very high level, are we? So there is, in principle, 3 options you can do. You can optimize on the motor, of course. This is more or less obvious, but you can optimize on the impeller as well, and for sure on the whole fan system, which means the nozzle is included there. So you have to have a look on the whole system. It's not sufficient to look only on one aspect at the same time. So yeah, it is possible to achieve higher efficiencies here.
Okay, I think 3 options, that's really a lot, and our sales colleagues will be happy to hear that. Then I would say we take a look at each of these opportunities, and let us start with the option number 1, the motor. So how a motor becomes more efficient, how does it work? I think we have prepared some slides, and the question is, may somebody explain it to our listeners how we can increase the motor efficiency?
Yeah, for sure. Let me do this one. Principally speaking, ZIEHL-ABEGG is offering the 2 different concepts. On the one side, we have the AC motor, the AC motor, which is generally talking about an axial fan and external rotor motor. We have some internal rotor motors with our medium pressure max vent fans, but in most of the cases, it's an AC external rotor motor. On the other hand side, we do have EC, electronically commutated motors. But what's the difference between those 2, and why do everybody says this one is more efficient than the other? Looking at this slide, you can see that every AC motor has a so-called slip. I mean, an AC motor needs to create its magnetical field. We have a wire, we have current running through it, we have the cage around, and with that, we create the magnetical field. In comparison to that, an EC motor has permanent magnets. So the AC motor has this slip, and this slip has losses. These losses we do not have with an EC motor because we have permanent magnets. Another advantage or big advantage of the EC motor is the easy speed control. So you can reduce the speed easily, and then you have, even in these cases, a way higher efficiency compared to the AC fans, depending on the technology, how you speed control them. But maybe on the next slide, I can show you the overview, generally speaking, about single-phase and 3-phase AC motors compared to EC Blue motors. And there you can see that the EC Blue motor is way more efficient, and we're going up to efficiency up to 90% on the EC motors. So all in all saying, because I don't want to go too much into the physics, means we have less losses at the EC motor, and we have way more possibilities to do speed control at still very high efficiency.
Well, Marco, I think that that's really a good explanation, but I think it's easy to point out the benefits of an EC motor, but let's not forget there are applications, especially low temperature applications, where the EC is just limited, so it's just not an option. Therefore, there will be a market, and there will be applications where AC is the only option in the future still.
Yeah, I fully agree, Torsten, because it's, like you said, the low temperatures, the challenge we have there with EC motors is that below around area of minus 35 degrees Celsius, we just lose the magnetical field. So this is the challenge what we have with the EC. So for these applications, and we have those blast freezers, other applications where it's just below minus 35, AC is just, as of now, the only option which we can go, and therefore there is a market, and there will be a market in the future.
Okay, thank you. We also see the same trend in the product management, right? The EC is a premium efficiency motor, but there are still requirements and applications in the market where you need AC fans. So the next question, maybe a little more difficult question is it possible to further increase the efficiency of an AC motor?
I'd like to answer this one. So it's not that easy. I mean, there can still be something done with the motor winding and maybe some percentage points there. But all in all, we're really at a high level here already. So this is really hard and comes with certain disadvantages. For example, with the ability of the motor to be voltage controlled or with the range of voltages it can operate on. So I don't think that's really our best option here. I think you have to go away or look outside of the box, outside of the motor, and look for the impeller or the fan system.
Okay, so it's not so easy to increase the motor efficiency of an AC fan. I think then we have to take a look at the second option, increase the efficiency with a more efficient impeller. So the next question is, how to make an impeller more efficient?
Well, let's take a step backward, a little bit in history possibly. We do have a lot of experience in looking to nature and take advantage of the insights the nature already has. This is then called biomedical designs, which means more or less we copy from the best engineer we possibly know, which is nature. It has millions of years experience. So we had there a very, very close look and we integrated in our new impellers a serrated trailing edge, of course, which is already known from former impellers. And we do have, of course, a winglet, which is copied from an eagle. You know that from airplanes as well. This is for efficiency and acoustic reasons for sure. And what is really, really new with our new impeller is a waved leading edge, which comes for improved efficiency and a better handling of unsteady inflow conditions, let's say. So this is really a combination of very, very much copying from nature more or less, and therefore we can go for higher efficiency with the impellers.
So does that mean the impeller will be enough to take some of the AC fans above the new minimum efficiency level?
Well, the impeller alone is not enough, but with that impeller in combination with our improvements we can do, this is then sufficient, for sure, yes.
Okay, interesting. Yeah, learning from the nature, I think, is always very interesting. The nature have a little bit more experience than the human race, and to look in the nature how efficiency is really working, I think that's really a good idea. So, coming to the next option, improvement of the fan system. You mentioned option number one is the motor. We have seen the slides and Marco explained. Then the next option was improvement of the impeller. But now we come to the third option, improvement of a fan system. So the question is how to improve a fan system, and I think for our listeners important, what do ZIEHL-ABEGG understand under a fan system?
Yeah, Uwe, I want to take this one because it's a daily business we are doing. I mean, fan system, what does it mean for ZIEHL-ABEGG? ZIEHL-ABEGG is a service provider, complete system provider. We are not only just selling the motorized impeller or even just the impeller, and you can match it with any motor on the market to have a fan which works. Yes, it's moving air in the end, but that's not what our customers are looking for. They are looking for a complete fan system which has the highest efficiency. And therefore, we provide the complete system, meaning motor with a perfect match to the impeller, but also having the inlet cone, bell mouth, guide vanes, complete system, because the customer is the one who has power supply. At the end, he wants to have moved air. Everything in between can be touched by ZIEHL-ABEGG, and we need to improve everything in between. So therefore, we need to take care that we have very good inlet conditions, that we have a good impeller and motor which match perfectly together and possibly are on the highest efficiency point which matches, but also the outlet conditions, which you can, for example, increase by having guide vanes or something like that. So all in all, we need to look at the complete system, power in, power out, and this with as less as possible energy. And that's what we call a fan system in ZIEHL-ABEGG.
Okay, thank you, Martin. So I think we have prepared some additional slides, and maybe the question is, are there any difference in fan systems, or as you said in the bell mouth? And for sure it's interesting how we can increase the efficiency of such a fan system. Maybe Michael, you can explain to our listeners how it does work.
Yes, we brought a couple of examples here. If you have a look on the slide, which should be shown right now, if you have, for example, a short bell mouth, which is often used in at very small diameters, this is a nozzle very small in actual dimension, and then you compare it to a full bell mouth, for example, and our most sophisticated nozzle system, the ZA+. I will come to that point later, what the ZA+ is all about. But before that, let's have a comparison of an identical fan in those nozzles. And if you have a look there on the graphs, you can see that there is a minor difference, or there is a difference, let's say, between a short bell mouth and a full bell mouth, which means the full bell mouth provides with a better performance curve than the short bell mouth does. This is the left-hand side graph here. And if you then have a look at the blue graph, this shows the ZA+ solution here. You see a tremendous surplus with the same fan, with the same impeller, with the same motor in the ZA+. This is a huge step forward with the same power consumption here. And if you have a look on the right-hand side, you can see the reason for that. Because the efficiency is way, way higher with the ZA+ in comparison to the full bell mouth. And this is what we see as a fan system, as Marco already mentioned on several points here, that we can achieve higher efficiency grades with our fan system. And if we have a deeper look in the system, which means the ZA+ itself, which is on the next slide then, we can see on the upper graph a standard fan or a standard nozzle, where you see the off-streaming of the air has a lot of circumferential components in its vector, and this is more or less the centrifugal, or the circumferential aspect is more or less a loss, and therefore we try to reduce with guide vanes those components and try to convert them into pressure. And there's one aspect the ZA+ does with its guide vanes. And further, there's a diffuser integrated, which turns the dynamic pressure into static pressure. And that is what mostly is asked for, is the static pressure rise. And this, both components in the ZA+ nozzle increase the efficiency a lot. And this is then the ideal solution for any customer, or if he wants to achieve high efficiency, at least then.
Thank you, Michael, for your explanation. I think it's really a great product. So question to our sales colleague. We have seen that ZA+ is really a unique product in the market. Maybe with the new design and this new composite material of the housing, at the beginning there are some challenges. So can you share your experience? How is the response in the market for the ZA+?
So in my opinion, the resonance is really good. Customers are happy or impressed by the performance and the workmanship. And now they even get the news that they might already have the right fan for the next ERP tier. So of course the customers that already have the ZA+ in their portfolio will be very glad to hear that their fans already reach over the new minimum efficiency. And so yeah, therefore with the ZA+, I think that's a product that puts us in a really good position right now with the ERP coming up.
Yes, I just want to add here that especially, I mean, in the American market, it was really a challenge at the beginning to have a fan with a composite material housing in the market, because the American market is very much into sheet metal. They know a lot about it since a lot of years, and they're very comfortable with using sheet metal. So for them, composite material at the beginning was very often used together with plastic, but this is just not the case. We're talking really about the high performance composite material, which is very strong, which has the same strengths like a sheet metal part. So There was a lot of discussions and a lot of work needs to be done to convince customers. We did presentations, we showed them our tests we have performed, but at the end, all of these customers were convinced by the unique selling points of this product. I mean, the high efficiency, the easy handling that you can stack them on each other, no corrosion. I mean, all of these advantages just convince the customers to use them. And nowadays I can say that this product is one of the most successful products for ZIEHL-ABEGG, not only in Europe, all over the world, also talking about the Americas, Asias. And it's really an excellent product in the market for all of the needs of our customers.
Okay, then maybe a little bit tricky question to our product expert. Yeah. We have seen with the ZA+, we can increase the fan efficiency. Is it really that simple that we say we install an AC fan inside the ZA+ and lift them up over the next ERP tier? Is it that simple, Michael?
It's not that easy in general, let's put it that way. For sure, for most of the cases where a FE2 outlet and a ZA+ is used with an AC, we will mostly fulfill ERP 2020X or the new ERP tier. But this depends a little bit on phase design and pole number as well. But for sure, for the major share, we can easily say that putting a FE2 outlet in a ZA+ will fulfill mostly the ERP targets.
Okay. And if the customer is not able to use a ZA+, which alternatives does we have in our portfolio or in the development range we are working in the moment? So are there alternatives for the ZA+?
Yes, if we have limited space, as you just mentioned, there is for sure another option. Yeah? For example, you can go for a more efficient impeller. We are here in the development process for those more efficient impellers, and this will be ERP conform even with AC solutions. And then you will be fine off even without a ZA+. As an AC solution, you will be ERP compliant, and you will be future safe there.
Yes, and I think this especially is FG range, what you're talking about. I mean, this is a very good product for us for the future when we, because of several reasons, are not able to use a ZA+, because this new series, which is under development right now, is really a new possibility to hit the ERP targets.
Exactly, that was what I'm talking about. Thank you, Marco.
Yeah.
Okay, then maybe at least let us take a look in the future. Which further options are there to increase the efficiency? Are there options to increase? So what do you think, colleagues? What possibilities are there to increase the efficiency further in the future?
There are always options, Uwe. I think there's never a limit. I mean, 10 years ago when I started in ZIEHL-ABEGG, everybody said we already have very high efficient products. We already are at the limit, but it still went on. New technologies, new ideas of our R&D colleagues. So there's always place to improve. So like mentioned, it's difficult to look just at the efficiency of each component. Looking at the motor of an EC, we are above 90% efficiency of just the motor. For sure, it's difficult to get more out of it, maybe a little bit, but the big trigger here is the fan system. Like I've mentioned before, fan system meaning complete motorized impeller, housing, inlet conditions, outlet conditions. So it's not only about the efficiency of the fan for sure that's the topic about ERP, but the customer also wants to have a good fan working in his unit. So there are also possibilities to have improvements in his units, and therefore we have experts to have good inlet conditions, which are very important for an axial fan, and also the outlet conditions can be improved.
I think that's an important point, because I think the challenge in the future will be to get even closer in contact with the customers, look at their projects when they are still on the drawing board, so we can have give tips or have an influence there as well, because the fan system or the unit system is not just our task, it's the task of the customer as well. And I think with our experience, we can often help them to optimize the airflow of their whole unit, of their whole application. So I think they are the measurements we do in-house with our fans, but with our customers unit as a whole, with the fan inside as well, comes really into play, and customers and we can benefit from that.
Yeah. I think it's common sense here in the round that we already at a very high level regarding the efficiency. And this is really a research we have to do to squeeze out the last percentage points here. It's really a hard task to get those efficiency point out of the existing fans or of the new impellers as well. But for sure we are thinking, or our engineers are rather thinking out of the box and having new ideas all the time and thinking about how to improve the efficiency further. And you can be sure that there will be some ideas for the next years to come to even improve the efficiency further. So please be sure on that point.
Okay, so thank you. Yeah, I think between your statement, I have a little bit listened. There are some options further to increase. So we will see what we launch in the next couple of years. I think very good and more efficient products. And from our administration team, I hear there is a customer question. And as mentioned at the beginning, we want to try to answer them directly in this roundtable. So Michael, it's a question to you. How many more efficient do you reach with a ZA Plus compared with a normal bell mouth design?
Well, this is a very good question, but not that easy to answer. It depends what is a normal nozzle here. Yeah? If you have, for example, a short bell mouth compared to a full bell mouth, this might be a complete different baseline here. But comparing full bell mouth versus ZA Plus, you can reach up to 15 percentage points more depending on the duty point, which is a big surplus here for an Axial fan, in my opinion.
Okay, thank you, Michael, for the answer. And I'm happy that there are more questions. Yeah, one more question is for Marco. Do you still sell fans that are not ERP compliant in the non-EU market, or do you take it off the market completely?
That's a good question, and I have a good answer for that. For sure, we're still selling products which are in our portfolio, which are not ERP compliant, to markets which do not require it. So still, you can get our products, talking about AC fans of older ranges. If you do not need ERP, we still sell these products. So ZIEHL-ABEGG will maintain the existing products, but also have new products with higher efficiency for the futures. So if you're talking about markets, US, China, where you say for the local market, we do not need ERP, for sure we still supply these fans which do not hit ERP. Because also like in China, we have local production of AC fans and we still supply the local market of these products with the AC fans which are already existing. So it doesn't mean that we take off the fans which are not ERP compliant.
Okay, thank you. I think slowly we come to the end, so I will make a short summary. We discussed about the new ERP tier and the higher requirement of efficiency value. And Michael explained us that there are three options. The first option was we can increase the motor efficiency by our Easy Blue motors. And I think this is really a good information for our market. ZIEHL-ABEGG is also able to increase the efficiency for an AC fan. This was the second option. We use a more efficient impeller design. And the third option, explained by Marco, we are thinking about the fan system, that we can increase the fan system to reach higher efficiency levels, especially with our unique ZA Plus. And we have heard it's a really good response in the market. So I think slowly we come to the end, and I want to give each of you the opportunity for a last final statement. Maybe Torsten, we start with your final statement.
All right. All in all, I would say ZIEHL-ABEGG is again in a really good spot and able to provide solutions to our customers for the next ERP tier.
Okay, thank you. Then who's next? Marco?
I can take the next spot. So I want to just say again that the efficiency of the components is getting harder and harder. We really need to look into the fan systems, think out of the box, make the complete fan system more efficient, and optimize these systems. Like said, ZIEHL-ABEGG is there to support the customers. Not only if you're already using ZIEHL-ABEGG fans, I also want to let you know if you're using other fan suppliers which are not able to provide you with any solutions for the new ERP tiers, you're more than welcome to get in contact with us. For the most of the cases, we have suitable solutions which will hit the target, and we are more than happy to work with you guys, with you customers, on these fans which you're actually using to have a solution for the new ERP tier.
Okay, thank you, Marco. And Michael?
Yeah, I want to conclude on Marco's statement as well. So we have available the full range of AC and EC fans, which then gives everybody the opportunity to purchase the right fan for the very application, and those solutions will fulfill the next ERP requirements or the next ERP tier for sure.
Okay, then thank you to my colleagues. Special thank you to Michael to jump in as replacement this morning. Summarize, ZIEHL-ABEGG will be able to sell AC and EC fans in the future to fulfill the next coming ERP tier. Thank you, colleagues, very interesting round. And to our listeners, I wish you a pleasant rest of the week. Stay healthy and goodbye.